Hi, my name is Christian Mendoza, and in this video we're going to go over how to create an LDT in the planet. First, let's go over the steps. Step number 1, you're going to switch the configuration to the planet, which you can see circled in red and labeled as 1 on the top right picture. Next, you're going to open the Dxf file of the part you want to work on, which you can see circled in red labeled as step number 2 on the top right picture. Next, you're going to figure out which is the top or bottom or the right or left side of the part in order to make sure you're creating the LDT in the correct place. Step number 4, you're going to create your X or Y reference lines, which you can see circled in red labeled as step number 4 on the bottom right hand picture. And step number 5, you're going to create your LDT, which you can see circled in red labeled as step number 5 on the bottom right hand picture. So I'm going to go over 3 examples. I'm going to create a relative LDT in terms of a hole. I'm then going to create LDT with the blade. And then finally, I'm going to create an absolute LDT in terms of a chicken notch. So let's go over the first example. We're going to create a relative LDT in terms of a hole. So we're going to go through the steps. First step is to choose the correct configuration. So we're going to go to configuration and we're going to choose the planet. You know, configured it to the planet because if you look up here in the corner, it says LDT planet. Next, we're going to open the Dxf file of the part we want to work on. So we're going to work on W75 3175. I'm going to click on it. So as you can see, 3175 is a stacked head. Okay. Now, we're doing a relative LDT. So the dimensions for this machine will be driven by the takeoff program. So we don't need to worry about where's the top or where's the bottom, or where's the left and where's the right, since this is a horizontal. So we're going to move on to the next step, which is creating the reference lines. So we're going to go to machines. We're first going to create the X reference line, and this is for the absolute LDT, so we're going to go not position reference, so we're going to do a relative, and the name is going to be X position. It's always going to be X underscore position for the X reference line, and for the Y reference line it's going to be Y underscore position. The default position will be 0. Now we're going to click end, and we've done the first reference line. Now to do the Y reference line. Now you can see how the reference line right now is positioned in terms of it going this way. But this is a stacked head. On the takeoff program, the X position is going to be this way, and the Y is going to be up and down. So we need to change the direction of this Y reference line. So all we're going to do is go up here, these 4 buttons, change the position of the machine. So we want to change our Y reference to this direction, since in the takeoff program the dimensions run this way and this way. So now we're going to go to non-positioned, and it's going to be Y underscore position 0. Now we're going to lock it to the back corner. So we're going to go up here, tools, we're going to put end, and we're simply going to click here, and you see the Y reference line moved. This means the starting point of this relative LDT is this point. So we're going to end this. Next is to create your LDT. We're going to create a hole. So we're in machining already. We go to standard machinings and we'll click on hole. Doing so, we'll open this table. Here you will put the dimension of your hole. So if we change it to 125, we see that the hole diameter changes. Our hole is going to be 0.188 inches, or 3/16. So here you choose the tools. You're simply going to tell the machine what tool to use. And we want to choose the tool that's closest to the diameter of the hole that we're creating, or the notch. So we're creating a hole that's 0.188, if we look at our tools, 2 of them are 0.187. Now, these tools have the same diameter, but one has the letter L at the end, which means it has an extender. So, this one, as you can see, does not have an extender in the tool. This one has this piece that makes it longer. So we don't want the machine to crash into the part, so we add this extender. But since our machine is going to be coming to the back of the part, we don't need the extender. So we're just going to go back and change it to the regular one. Our next window that opens up. Here, we could change the location of this machine by simply changing your WHX. As you can see, this is going to match your location down here. So, X is going to move right or left. So, put 1, it moved right. You see? Now, H is going to be up and down. So, if we put 1, it's going to move up. And our W is going to move in and out. This is a relative LDT, so we're not going to change anything in this window. But what we are going to do is we're going to tie this machining to your X and Y reference. Because your X and Y reference lines are what's going to tell the machining the location of the LDT. And that's going to be driven by the takeoff program. So we must connect this machining to your X and Y reference line. And that's very simple to do. All you're going to do is click on this line, and you see, link current machining to the vertical reference line, X position. You're going to say yes, and then you have to link it to the Y position. Make sure you click the Y. It's going to say link current machining to lengthwise reference, Y position. You're going to say yes. And doing so, you're going to see this machine can change from location, from being down here to coming up here. Because this is where the X and Y reference lines intersect each other. Now we're going to move on to the next window. So here we have this Z values intersection. So we have the start, end, and release. So to start, this is telling the machine how far from this starting point is this machine going to start drilling the hole. Right now we have 1 inch, which means that from this point to the point that the drill bit starts rotating is 1 inch. Now we don't need it to be that big, so we're going to change it to 0.06, and you're going to see it going to go from here all the way down here. See? So now we're telling the machine, when you get 0.06 of an inch away from the starting point, you can start drilling. Now the end is from this point to the end. So until when do you want the machine to stop? Right now it's 1 inch. So from here to here is 1 inch. The way that you determine how long this has to be is simply by how much of a material you're going to drill it in. Since this machining is just going to drill through the bottom of this part, you don't need it to be that long. 0.4. And that should be plenty enough to drill through this wall. And if it lands on this raceway, it should be long enough to clear the depth of the raceway. Now the release is how far back the part will move from the starting point when it's changing from one hole location to the other. So right now we have it at 1 inch. So from this point to this point, we have 1 inch. Now, this is very important because if we put it to move very far, it's going to take a long time. So typically, we like to put ½ inch. And you see, it's plenty far enough. Now, if we were drilling a hole from this side, we would need it to move all the way past the chicken head in order to make sure that the machine won't crash with the chicken head when it's moving to different locations of the hole. And that's what the start and the release mean in this window. And now we're going to press finish. And you have created your first hole in CAMplus. So we're going to start our second example. So let's go down the steps. First, we're going to configure it to the correct machine, which is the planet. Then we're going to open the Dxf file with the part we want to work on, which is W75-3175. Next, we're going to figure out where's the left and where's the right of this part, so we can make sure we're going to create the LDT in the correct side. So let's open the fab ticket in CAD. So here's the fab ticket. We're going to go to model space, and we're going to orientate this the same way as in CAMplus. So as you can see, the same orientation. You see it's the same orientation. So if we go back to CAD, we see that this is the left, where our notch is going to be. We're building this 1 1/4 inch notch. And we know that's on the left side. And we know that we must build our notch on this side. So next we're going to create our X and Y reference lines. So if we look at our CAD, we see that we can build 1 X reference line, and that will be enough, which will be the 1 1/4 inch X reference line. We're going to go X reference line. We're going to say 1 1/4 inch. There you go. And now we're going to look at this from the top, and this machining is going to be created with the blade. More specifically, the horizontal blade. So we're going to choose our tool. We're going to put after separation cuts because it's the planet. Now here, we choose what corner we want our cut to be on. So this one stands for this corner. This bottom left stands for the bottom left corner. Top right stops for the top right. And the bottom right for the bottom right. So we want our notch up here. So we're going to click on this one. Now our X is 1 1/4 inch. And then for our W, what we're going to do is we're going to go to CAD, and we're going to get our measurements from here. So we're going to do 3.688 minus 1.313, and that's our W. So let's go back to CAMplus, and our W, we're going to put 2.375, and we're going to click Finish, and there you go. Our notch is complete. Now let's go over another example. For this example, we're going to build a chicken head notch. First, we're going to choose the correct configuration. So we go to Configuration, and then click on it. And next, we're going to open a Dxf file of the part we want to work on. So we go to Dxf profile. We're working on W75-5263. And here we have the part open. Next, we need to figure out what's the top and what's the bottom in order to know where to create this LDT. So we're going to open CAD, and we have the part open here. And now we need to orientate this the same way as CAMplus. So here's the orientation in CAMplus. It's like this. Now we see that the bottom's over here and the top is over here. So we go back to CAMplus. We know that the bottom's down here and the top is down here. So now that we know the top is here and the bottom's here, we start building our reference lines. So we go back to the fab ticket. We see that for the X reference lines, we have a dimension for 7/16 for this small notch down here, and then the two big notches are both 2 3/16. So we need to create two reference lines, one for 2 3/16 and one for 7/16. So we're going to go to Machines, X reference line. So you see the X reference line is down here, but we want it up here. Now this is considered the max. So in order to get the X reference line 7/16 from the bottom, we're going to say max minus 7/16. And you see it moved 7/16 from the bottom. Now same thing for the 2 3/16. So we're going to say max minus 2.1875. And there you go. We have both the X reference lines. So now that we have the X reference lines, we need to make the Y reference lines. So we look at our fab ticket in CAD. We see that for the first notch, we're going to work on this notch, we have 7/16 from this point. So if we go back to CAMplus, we have the Y reference line. Gotta change it this way. Gotta lock it down here. As you can see, the Y reference line moved 7/16. So if we go back to CAD, we see that the second reference line is going to be 7/16 plus 3/8. So that will equal 13/16. So now let's go back to CAMplus. So we're going to go ahead and click on the Y reference line, and then we're going to say that the starting point is going to be at this corner, and in the position we're going to put 13/16, and that's going to move the Y reference line for us. And there you go. We have our second Y reference line. So we go back to our fab ticket, we see that we can make another Y reference line for this point, which is going to be 7/16 plus 3/16, which will equal 5/8. Back to CAMplus and click on the Y reference line, click the starting point the same as the other ones, and the position we put 5/8, and that's going to give us our third reference line. If we go back to our fab ticket, we see that for the second notch from the same starting point to this point is 2 inches and 5/8. So if we go back to CAMplus, click the Y reference line once again, we tie it to the same starting point, and in the position we put 2 inches and 5/8. And then now we have another Y reference line. So now if we go back to CAD, we see that the notch is 5/8, so we need to make another reference line. So we have 2 inches 5/8 plus 5/8, which is 3 1/4. So we go back to CAMplus, click on the Y reference line, we tie it to the same starting point, and then in the position we put 3 1/4, and we have a final Y reference line. So we can actually build one more reference line, which will be an X reference line. This reference line will show the limit of the machine. So you can't create any machine past this reference line. So we're going to go to X reference, max plus 1/8. As you can see, reference line was created right here. This is the limitation of our machine. So you can't build any machines to the left of this line. So let's go ahead and build our first notch. So let's go back to our fab ticket. And the first notch that we're going to build is this one. As we can see, it has a width of 5/8 and a length of 2 3/16. So the way that we're going to make this notch is with the rectangle. Now, we need to make sure that the machine is coming from the right direction. We want it to come from the right. So we're going to go up here in the axis. As you can see, it changed where the machine will be coming from. Now it's coming from the right direction. So the width of our slot is 5/8, but we're going to add a small tolerance into it. So we made it 0.644. And the height of our slot is 2 inches 3/16, but we're going to add 1/8 to it in order to make it a nice clean cut at the bottom. Now the radius of the cut on the corners, we're going to make it 1/8 in order to make it as sharp of a cut as possible on the corners. Now this rotational angle rotates your slot. Right now it's at 180 degrees, so it's correct. so we're not going to change anything. Now here, we choose the tool that we want to use. It's going to give you the tools that are all capable of making that slot. We're going to choose the M250. And then we're going to click after separation cut because this is the planet, and the planet cuts the part from stock length. Now we need to make sure we click the correct reference lines. So we know the height of our slot is 2 inches 3/16. So we can choose the X reference line, that's 2 inches and 3/16. So you can see that brought the slot all the way down here. Now we're going to click this reference line because we don't want our machining to rub against this leg. So we're going to click this reference line, and this slot is going to move to the intersection of this Y reference line and this X reference line. Now we see it from the front. We want this slot to land between these two reference lines, because these two reference lines illustrate the correct location of this slot. So we have to change our H, and here we're going to put half the width of this slot, since half the width is inside and half the width is outside. So we're going to put minus 0.322, and as you can see, the slot moved in between these two notches. Now remember, we built a small tolerance into it, so as you can see, it slightly goes over the reference line, but that's fine. Now if we look at it from the side, we need this slot to land between this reference line, which is our 2 and 3/16 reference line, and this reference line. So we're going to go into the X slot. We're going to put half the length of the slot. And as you can see, it moved in between these two reference lines. Now that you know it's in the correct location, you're going to move on to the next window. Here for the start and end release, here we're going to put our standard numbers in. So for our start, we're going to put 0.06 of an inch. Our end, we're going to put negative 0.4 of an inch. And our release, we're going to put half an inch. And we're going to click end. And that's our first slot. Now we have to do the other notch, which is the notch back here. If we look at the fab ticket, this is the notch that we have to do. So we have to do one small notch that has a height of 7/16, and then we have to do one big notch with the size 2 and 3/16. Now remember, the X reference line for this small one is 7/16, and the Y reference line is the 7/16 plus the 3/8. So we go back. So we're going to use a slot machine. So we go to machines, click on slot. You're just going to open this window. First, you want to make sure the machine is coming in the correct direction. So you want the machine coming from this side. So you're going to go up here in the axis, change it. Okay, now you see it's coming from the right direction and it matches this machining. So now we're going to go into this window. We're going to change the width of the notch and the length. The width is 3/16, so the width is fine. The length, you see it got smaller. This angle rotates this notch. Right now it's at 180 degrees. If we put 90, this notch will move up. Right now it's correct, so now we're not going to do anything. Next, we're going to choose a tool that has a diameter that best matches our notch. For this, we use the M188. We're going to put after separation cuts because it's the planet. Now we need to choose the correct reference lines in order to make sure the slot is in the correct location. So we're going to choose the X reference line, 7/16. Now we're going to choose the Y reference line. Now we're going to look at it through the front. Now we need to move this slot in between these two reference lines in order for it to be in the correct location. So we're going to have to move the H. So we're going to go up here. We're going to put half the size, or half the width, since half the width is inside and half the width is outside. Move to the correct location. Now we need this slot to be in between these two reference lines, this being the 7/16 and this being our limit of 1/8. So we have to put half the size again, but this time half the length. And there you see moved into the correct location. Now, to look at it sideways, start, end, and release, we're going to put our standard dimensions in. So 0.06 inches, start, minus 0.4 inches, end, and the release ½ inch. And that slot is complete. Now we're going to do this slot, which has a length of 2 3/16 and a width of 3/16. So we're going to go to slot. Once again, we're going to make sure the machine is coming to the right direction. The width of the slot is correct. Just got to change the length. Now I have to click on the correct tool. We're going to use the same one, M1A8. Now we have to click the correct reference lines. So for the X direction, we're going to choose the 2 3/16. And for the Y direction, we're going to use the 7/16. Now you see we need to move it in between these two slots in order for it to be in the correct location. There you go. And now we need to move it down in between this reference line and this reference line in order for it to be in the right location, which is your X. So it's going to be half its length. And there you go. It's in this correct location. And then the start, end, and release is going to be the same as the first file. And now you have a complete chicken head notch. And that's how to create an LDT in the Planet. Thank you for joining me. Goodbye.